Our lesson plan is over force and motion, and our TEKs are for science and English language arts. Our science TEK is force, motion, and energy. The student knows that energy exists in many forms and can be observed in cycles, patterns, and systems. The student is expected to design an experiment to test the effects of force on an object, such as a push or a pull, gravity, friction, or magnetism. Our ELA TEK is listening and speaking and teamwork. Students work productively with others in teams. Students continue to apply earlier standards with greater complexity. Students are expected to participate in teacher and student-led discussions by posing and answering questions with appropriate detail and by providing suggestions that build upon the ideas of others.
For our objectives, the first one is the student will create a written list of 5 examples of motions. The teacher will make the force and motion T-chart available for reference. The second one is that the student will conduct an experiment that shows how varying force, mass, and surface texture will affect the distance traveled by a car.
Hi, for Engage, the teacher will first introduce the students by reading the book Sheep in a Jeep by Nancy Shaw. This will introduce the students to the concepts of force and motion, as well as to the force and motion that we will do later in the experiment. The teacher will then form a T-chart by writing the words force and motion on the board and allow the students to complete questions that she asks. Some of the questions we will ask for the T-chart are, what is force? And can you give some examples of force? And is gravity a force? What is motion? And so on.
For the explore part of this assignment, we're going to let the kids play with our cars on the ramps. What they're going to do is they're going to put the Jeep on the ramp and let it go. Okay, and what they do is they measure the distance with the measuring tape between the end of the block and the car. And they write it down on the sheet that we have for them. They're going to do this 3 times, and then their next task is to see what happens when they add more friction, different kinds of friction or variables to the ramp. So they can put the sandpaper on the ramp, and then they'll put the foil, and they'll do each of these 3 times and write it on the sheet. Before they start, we'll ask the kids several questions to get their minds thinking, like, how are we going to release the Jeep to roll it down the ramp? How are you going to measure the distance that Jeep travels once it's off the ramp? And finally, for their hypothesis, they will ask this question, on what surface do you think the Jeep will travel the furthest? Okay. Before they start, they'll write down their hypothesis, they'll do the experiment, and then they'll see if their hypothesis was correct or false.
After students are done completing their experiment, the whole class will have a discussion. Each group will discuss their results, and students will consider whether or not their hypothesis was correct. Then, the teacher will discuss the concepts of friction and the role that friction played in this experiment. Some of these questions will be asked. What made you choose the hypothesis that you did? Was your hypothesis correct? Did every group get the same results? How did gravity play a role in the experiment? What is friction, and how did it play a role in the experiment?
For the elaboration part, the students are given additional supplies. Pennies to add to the bed of the truck for weight, more weight. Tape to see if, when you put tape underneath the tires of the truck, to see what would happen. And also you can change the angles by adding or taking away wooden plots.
For the evaluate section of our lesson plan to assess what the students have learned during their experiment, we will discuss as a whole class what force, motion, and friction is. We'll have the students repeat them orally. The students will also come up with a list with 5 examples of force and 5 examples of motion from what they learned during their experiment. They will also define friction in their own words. And last, we will ask them to answer the question, would a car travel faster on smooth concrete or on gravel, and why?